Hello everyone, welcome back to my channel. Myself is Arun Kashish. In this video, we are going to find the range of the function y is equal to 1 upon fx. That is, we are going to find all the possible real values of y equals to 1 upon fx whenever defined. First of all, we find the range of fx. Three cases arise. Case 1, when all the values in the range of fx are positive. We take reciprocals on each side to get the range of 1 upon fx. In case 2, all the values in the range of fx are negative. Again, in this case, we take reciprocals on each side to get the range of 1 upon fx. Now, case 3, the values in the range of fx are positive as well as negative. In this case, we split the range into two parts, positive part and negative part. We discard 0 from the range of fx as denominator of a real number is never 0. Again, taking reciprocals on each side to get range of 1 upon fx. For example, let us find range of y equals to 1 upon ax plus b. The range of the linear function ax plus b is from minus infinity to infinity. The values in this range are positive as well as negative, minus infinity to infinity. So, we split the range into two parts. Negative part is from minus infinity to 0 and positive part is from 0 to infinity. Of course, we discarded 0 from the range of fx. For the negative part, minus infinity to 0, when we take reciprocal, the numbers which are tending to minus infinity, their reciprocals will tend to 0, and the numbers which are tending to 0 from the negative side, their reciprocals will tend to minus infinity because the numbers are negative, so reciprocal must be negative. Inequality sign will change on taking reciprocal. So we get 1 upon ax plus b. In this case, is from minus infinity to 0. And for the positive part, 1 upon the number tending to 0 from the positive side tends to infinity. And 1 upon infinity tends to 0. So again, inequality signs change. We get the range of 1 upon ax plus b as from minus infinity to 0 or from 0 to infinity. We can write it as r minus 0. Let us take some more examples. Y equals to 1 upon x square plus 9. Now, x square plus 9, its range is from 9 to infinity, as we all know. We have discussed in the previous videos. So, all the values of this range are positive. Taking reciprocals, 1 upon 9 is greater than or equal to 1 upon x square plus 9 greater than 0. So, range of the original function 1 upon x square plus 9 is from 0 to 1 upon 9. 1 upon 9 is included, 0 is not included. Next example, let us take and use the fact that range of ax square plus bx plus c when a is greater than 0 is minus d by 4a to infinity, that we have discussed in the previous videos. We are going to find range of this function y is equal to 1 upon 2x square plus 5x plus 4. Coefficient of x square in this case is 2, which is positive. So range is from minus d by 4a to infinity. Find d. D is coming out to be 25 minus 4ac is 32, that is minus 7. So minus d by 4a is 7 upon 8. So 7 upon 8 is less than or equal to 2x square plus 5x plus 4, less than infinity. Again, all the values of this range are positive. So taking reciprocals, we get 8 upon 7 greater than or equal to 1 upon 2x square plus 5x plus 4 greater than 0. So range of the original function 1 upon 2x square plus 5x plus 4 is 0 to 8 by 7, including 0 but not including, including 8 by 7 but not including 0. Again, next example, let us take y is equal to 1 upon x square minus 5x plus 4. Now, again, in this case, coefficient of x square is positive. Its range is from minus d by 4a to infinity. So minus d by 4a, we can find it is minus 9 by 4 to infinity, including minus 9 by 4. Now this range has positive as well as negative values. We split the range into two parts. Negative part is from minus 9 by 4 to 0, and positive part is from 0 to infinity. Discarding 0. Now taking reciprocals. Reciprocals are minus 4 by 9 greater than or equal to the reciprocal of x square minus 5x plus 4 greater than infinity. From the negative side, minus infinity, because all the numbers are negative. And on the right side, when 0 is less than x square minus 5x plus 4 less than infinity, taking reciprocals, we get infinity greater than 1 upon x square minus 5x plus 4 greater than 0. So the range of this function becomes range of the original function is then minus infinity to minus 4 by 9 union 0 to infinity. Alright, now let us take y is equal to 1 upon square root of 2x square plus 5x plus 4. We have discussed the range of 1 upon 2x square plus 5x plus 4 in the above case. So again, 2x square plus 5x plus 4 lies between 7 by 8 to infinity, including 7 by 8. The values are positive. Taking square root on each side, we can take square root on each side. Square root of infinity is infinity, and these values are again positive values. So taking reciprocal, we get under root of 8 by 7 is greater than or equal to 1 upon under root of 2x square plus 5x plus 4 greater than 0. So range of this function 1 upon square root of 2x square plus 5x plus 4 is then 0 to under root of 8 by 7. Next, let us take y is equal to 1 upon square root of x square minus 5x plus 4. We have discussed the case y is equal to 1 upon x square minus 5x plus 4. Its range is from minus infinity to minus 4 by 9 or from 0 to infinity. Now we have to take square root, so we discard negative values because we cannot take square root of negative values. So we only take the values from 0 to infinity to take square root. So we take the values from 0 to infinity, and we have discarded 0 also, and on taking square root for these values we get the range of 1 upon square root of x square minus 5x plus 4 as 0 to infinity. Next is y is equal to 1 upon minus x square plus 5x minus 4. Here the coefficient of this quadratic function, coefficient of x square is negative, so a range of these functions is from minus infinity to minus d by 4a. So its range will be from minus infinity to minus d by 4a. What is d in this case? It is b square minus 4ac, 25 minus 16, 9. So minus d by 4a is 9 by 4. Minus d by 4 is 9 by 4. These values are negative as well as positive, so we split into two parts. Negative part is minus infinity to 0, and positive part is from 0 to 9 by 4, including 9 by 4. Taking reciprocals, reciprocal of minus infinity tends to 0, sign changes, and reciprocal of 0, which is from the negative side, tends to minus infinity, sign of the inequality changes on taking reciprocals. So we get 1 upon minus x square plus 5x minus 4 lies in this interval for the negative values, and for the positive values we get infinity greater than 1 upon minus x square plus 5x minus 4 greater than or equal to 4 by 9. So the range of our function y is equal to 1 upon minus x square plus 5x minus 4 is then minus infinity to 0, union 4 by 9 to infinity. Now for this function we discard the negative terms in the range of 1 upon minus x square plus 5x minus 4, and then taking reciprocal of the remaining, the range is